Let's look at LeetCode problem number 463, island parameters. Let me quickly explain the problem. If you got it, feel free to skip this part. So here we are given a matrix containing zeros and 1. There is an island made up of these ones. The ones are connected only by sides, not diagonally. So in this example, we can see that this one is connected by this one, and this one is connected by this one, and this one and this one. So I hope you have got it. So the key thing to know here is that in the matrix we have only one island, not more than one island. So what we want to find out is the parameter of this island, that is the number of edges connected to water. In the example, we can see that this island is connected by this edge to water. This edge is also connected to water. This edge is also connected to water. This we won't count as it is connected by another island. So in this problem, we can see there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16 edges in total. So the answer for this problem will be 16. As you can see in the example, it is 16. So now let us look at the naive solution to this problem, which is pretty easy. What we can do is traverse the matrix row-wise. While traversing the matrix, whenever we find 1, we will check all of its neighbors. If the neighbor is out of bound or it is 0, it means that edge is surrounded, it's on the water side. So we will add in the counter. So let's maintain a variable counter cnt, which is initially set to 0, and continue traversing the matrix. Here we find 1, and if we look at its neighbors, this is 0, this is 0, and it is out of bound, and this is 1. So this edge and this edge will be added in the parameter, and this will be ignored as it has the island cell. So our counter here becomes 3. Again traversing the matrix, we will go to this one, and for this one we have this edge, left edge and the bottom edge. So again our counter will be now 3. This edge will not be added. While doing so, we will check for every one. This one has no neighbor edge, which is surrounded by water. Then this edge and this edge, again our counter. Here, sorry, it was 6. Now it will become 9. Now again for this one, we have this edge and this edge, so our counter becomes 11. Again traversing the matrix, for this one it will be this top edge, left edge and bottom edge, so it will be 14. And for this one we have these two edges, so our answer will be 16. And again in the matrix we won't find anyone, and we will return this counter. So that will be our answer to the naive approach. Now let's look at the optimal solution which I could think of. In the naive solution, we were not using the information that there is only one island in the grid, and so we can solve this using DFS. So let's try to trace our algorithm. We will traverse the matrix, and as soon as we'll find 1 here, we'll call the DFS function. So the DFS function will be called from the main function by this cell, from this cell, and then it will call all of its neighbors. So it calls above, it is out of bound, and so it will return here 1. It simply means that this edge is surrounded by water. Similarly, then it will call the left cell, it will return here 1. It will return here 1 as this is also a water cell. Then let's say it goes to its right, then it will also return here 1. And now it calls the bottom neighbor, it is 1. So now this will call all of its 4 neighbor, and to ensure that this doesn't call the above neighbor again, and so that it starts doing DFS again, and that will consider the edges twice, we will have to somehow mark it as visited. So we can use a visited matrix, or we can just turn this 1 to some number which is not used anywhere. So let's make it 2. So I'm making it 2 just to mark it as visited. Otherwise, in the matrix, we will have to use extra space. Now, for this one, when it will call this function, it is already 2. So this will return here 0. Now this will call left, and as this function now will call, okay, as before making the calls, we have to make it 2. So here I will just go back, and as the call was made to this one, we will make it 2. So we'll make it 2, and now let's call its neighbors. So this will call here, and now from above it will get 1, from here it will get 1, from here it will get 1, and from here it will get 0. And this here, the function will return the sum of all of these, like this one, and this one. So here it will return 3, and now it will call the right neighbor. The right neighbor similarly gets 1 from here, 1 from here, 1 from here. It will, I'm forgetting to mark it as 0, but when we write the pseudocode, you will really understand how does that work. So it will be 2, it will be 2. So here it will be returning 3 here. So now this function calls it there, and this here it will get 1, here it will get 1, and we'll change it to 2 as well. Now this calls here, and this will call here, and marking at visited 2 and 2. So now at this will return 1, this will return 1, this will return 1, and when it will try to call this one, it is 0, already visit, so it will get 0. So finally what this cells return here is some of these, so 3, and here it will get 1, here it will get 1, and the sum of this will be returned to this cell as, let me use another color, let's say this one. So now it will be sum of this, and this, so it will be 5, and from here it get 1, 1 and 5, so it will return 7 here, it will get 7 here, from here it get 3, 3 and 7, so in total it will be return here sum of these 3, this and this, which is 13, and from here it get 1, here it get 1, and here it get 1. So the sum will be written 1 plus 1 plus 1 and 13. So this and this, we will get the answer as 16 will be returned to the function. And as we can see that we have traversed the island, and there is only one island, so we will break our loop of traversal in the function. Let me show you how. So now quickly moving on to the pseudocode of this optimal solution. Optimal solution is the pseudocode. So in the island parameter function, island parameter, which has grid, what we will do is traverse this grid using 2 loops as we do for matrix. For I in row and for j in column. If we find 1, so if grid I j equals to 1, we will call the DFS function over it. So we will call DFS, and DFS will take grid I and j, and DFS will return us something. So let's that will be our answer. So we will return this, return DFS. Now, as this function will return from here, it will give you an error if you don't return something here, as we might not find 1 here. So what we can do is, by default we can here return 0. So this completes our is parameter function. So now let's look at the DFS function. DFS function will take a grid, the coordinates I and j. So first let's write the base case. If we find that the current cell is 1, so we have to, okay, so let's look at this way, that if the DFS will be called to this one, and then this one will call the DFS to all of its neighbors. So if it goes out of bound, for out of bound we have these 4 conditions, that if I greater than equals to grid dot size, or j greater than equal to grid of 0 dot size. As we can say, we can't say that the matrix will be square, so we have to use a grid of 0 dot size for j. And for the third condition, we have I less than 0, or we have j less than 0. It means we are out of bound. So as we look in the trace of the algorithm, the function should return here 1. Then if we find that the current cell, if grid of ij is equal to 0, that is the current cell, it should also, that is the water cell, should also return 0. It should return 1. While if the grid ij is equal to let's say 2, which we are saying that it's marked as visited, we should return 0 from there. So now if the current cell is 1, that is we are left with grid of ij equal to 1, as all of these conditions are false. So as we know that we were returning the sum of all the DFS calls around the cell, so the top neighbor will be in n1 is equals to the top neighbor here will be grid of I comma j minus 1. Similarly, the lower neighbor will be I of j plus 1. The left neighbor will just be I minus 1. Let's make the right neighbor I plus 1 comma j, and the left neighbor then will be I minus 1 comma j. So we'll call the function so all these coordinates. So int n1 is equals to solve on grid, not solve, in my code I have written is solve. Here we are using DFS, grid I j minus 1, int n2 is equals to DFS grid I comma j plus 1, int n3 is equals to DFS grid. What we are doing here is making all the calls to its neighbors. So now what this bracket is doing here, I plus 1 comma j, and int n3 is equals to DFS on grid I minus 1 comma j. And now we will return the sum of all these. So return n1 plus n2 plus n3 plus n4. This will be n4. So this is the complete pseudocode. I hope that you have understood the problem. If you have a better solution to this problem, comment down below. If you like the video, please like it and tell me how was it and what are my scope of improvements, either in the solution or making the videos. I'm also just a college student trying to be better at LeetCode. So yeah, that's all for today. Bye.